Welcome, good morning. Today this session is on data lakes with Azure Databricks. So I'm assuming that some people in the audience know quite a bit about data lakes but are curious about Azure Databricks and Spark. That some people in the audience don't know much about data lakes and are more looking for that introduction and may or may not know something about Spark. And some people know a bit about either but want to see my perspective, what I have to say about it. And maybe they caught that I'm going to show some streaming with Spark and Event Hubs. And so we will be looking at some code, but you don't have to follow the code in depth in order to get value out of this. We will not be teaching you the syntax of Spark very well. We'll be mostly talking about concepts, showing some demos of how we can do different things with Spark and Azure Databricks. And that being said, let's get going. So my name is Dustin Vannoy. I'm a data engineering consultant, which means for the last year, I've been working with a few different companies. Early in my career, I was doing data warehousing and business intelligence with SQL Server, SSIS, business objects, and other tools. And now, for the last 5 years, I've been doing more data engineering type of technologies. And so I have blog posts on the difference between, or what a data engineer is if you really want to get in the weeds about it. I'm pretty open. For me, though, once I went to programming my ETL with Python, doing a lot of cloud work with databases as a piece of it, but Python and other cloud services as part of it, I started calling myself a data engineer. And so that's kind of where I'm coming from, is this modern data systems focus for the last several years now, using Azure and AWS. I mostly talk about Azure these days. That's been my primary focus for the last year, working with Spark and Kafka and Python. We'll talk about all of those a little bit today. You can contact me on LinkedIn, follow me on Twitter. I would love to hear from you or have you keep an eye on what I post and what I share in the future. And really important, this is not a past group, but we have a data engineering San Diego group that is virtual for who knows how long, for maybe the rest of the year. And I'd love for you to join us. We meet usually the first Thursday of the month. You can find us on meetup.com or just follow me and find that info. And we talk about all kinds of technologies. So the agenda, I'm going to define data lake. I would love to hear, if you know a lot about data lakes, I'd love for you to hit me up with your perspective, either in the chat or you could save it and we could get a conversation going offline. But I'm going to tell you what I think is important about data lakes, why we build them. It's going to be a little bit biased, but it's pretty common agreement in the industry that these are things that you may choose to do with the data lake. We're going to focus on Azure Databricks as a key component of using data lakes in Azure. And so there are some different options these days. I'm going to focus on Azure Databricks and talk just a little bit about the others as we go. We're going to look at a reference architecture and some code that is symbolic of what we would have in a real code base. And so we'll look at Databricks and PySpark code. We'll look at data lake storage. Mostly we'll be leveraging it, but I'll explain it a little bit. And then we're going to talk about Kafka and event hubs for Kafka and how we use that from Azure Databricks, because I find that's how I tend to build data lakes. And I think it's a good architecture in many cases. And I'll tell you why as we go. So data lake, the simplest way I can describe it, this is probably a little too simple, and so I do have more slides, distributed storage for big data. We are trying to collect probably a lot of data, and we want it to be distributed and easily scalable, and a few other things. So to dig into this definition, we expect to have varied data. We almost always talk about raw data going into a data lake. Sometimes that's where people leave it, and they say the data lake is where you put all this raw data, and you just kind of organize it however you want, and that's where the raw data goes. Everything else is going to go into a different environment. I like to use a data lake where you do have that raw data coming in. That's super important and super helpful, especially for data science work. But we also then process the data, and as we're processing it, we sort of put that intermediately processed, somewhat cleaned up, somewhat transformed data back in the data lake. Similar to if you're doing data warehousing, ETL, and staging the data along the way, usually it's kind of for the internal troubleshooting use. It's that sort of concept, except we're actually trying to expose some of that data for others to use. And then I really encourage people to put a lot of, maybe all of your fully processed final tables into the data lake as well, so that people can access them through the data lake, so that you can keep all your history there. And when it comes time to know what the right answer that the chief financial officer is looking at is, you have that answer in your data lake and any other places you need it to enable reporting. I think a data lake must be ready for analysts to use. So it's more than just storage. It's more than a file system. There needs to be query layers and analytic tool access. If the data lake is there, if you give people some amount of access, they can throw these tools on top of it. But typically, I really suggest organizations have the team that's building a data lake also provide some sort of default querying capability that they can help teams get set up with. I've seen that be sort of an afterthought, and I've seen it cause a data lake to be expensive and collect a lot of data but not get heavily used. Big data capable, we're going to talk about big data quite a bit through here. It may seem like a buzzword, but it's a different way of doing things. And so I like to call out that if you have a pretty small amount of data, say you have a terabyte of data, you're doing fine structuring it, you're doing fine in SQL Server, maybe a data lake isn't beneficial. We'll talk more about that. But basically, we want to make sure we can store this data first and evaluate and model it later. So the reasons why, we're going to go with 3 reasons why we love data lakes. One is to store everything. So we have this variety of file formats. So CSV to limited files you may be pretty familiar with. JSON you're probably familiar with by now. But log files, text files, XML if you really want to work hard, Parquet and other formats that we'll talk about. All these different formats can be stored in the data lake pretty seamlessly. You can store data without putting a schema when you write it to the data lake. It's always nice to have that schema there, but if you just need to collect data for future use cases, you don't know exactly how it's going to be used, you aren't forced to have a well-modeled, well-schema set of data. And you can have cheaper storage, which is where the cloud's really beneficial, though there's other ways to do this on-premise and get better bang for your buck when it comes to storage. Reason number 2 is this massive scale, this big data. So we're talking about large volumes data or data that comes in very fast, which usually if it comes in really fast, it's going to add up to large volumes in the future. And we want to make sure we can scale up our storage easily and scale up the other systems easily that are working with the data. We want to be able to span hot and cold storage. This is maybe more of a benefit of certain cloud providers rather than a requirement, but typically you're going to find you want to be able to have different tiers of storage that will help you get better cost savings, help you get the performance you need for the really important, heavily used data. And we want to pay only for what we need. Mostly this means we don't want to have to provision 4 terabytes of expensive disk right now, knowing that we'll get there in 2 years and it's such a pain to get new disk installed. So we want to go down a path where we can say, we need a cloud storage solution or we need a distributed cluster that's easy to add to, and we will just add on as we go rather than plan that far ahead and pay for all that storage that's not being used. Reason number 3 that I look at for data lakes is storage and compute being separate. You'll hear about this a lot as you go to the cloud. If you haven't been focused on Azure or any cloud providers yet, you may not have heard this as much, but we're at this point where we can start to store data, store information on completely different layers that are scalable, fault tolerant, a lot of really good capabilities, and then we could have the processing be separate. What's great about that, and I'll show you this, or I'll talk about this, is we can actually turn off our compute during the day, or during the night, let's say, if we're not doing any processing at night, turn it back on during the day for querying, scale up when it's a heavy load time, scale up when we have a new department start to use this thing, and we're paying way less for storage than we are for all the processing power that sits on top of the storage. That's a lot harder to do if you're not in the cloud. Data lakes still may provide some of that if you're not in the cloud, but that's kind of a big capability that cloud data lakes provide in particular. And with this comes some cost savings. With this comes the ability for teams to choose what tool they're going to use, what tool they think they should be experts in order to do their job well, rather than having to fight and battle over which enterprise solutions are allowed. Many other reasons that may still be the case, but data lakes might give you more capability to have a variety of solutions that better fit the different use cases. Now, maybe you followed that and you're new to data lakes and you're wondering, but what about the data warehouse? I thought I put all my data there. I thought I cleaned my data there. Well, sure, you can. And really the way I look at data warehouse, if you're in this bigger data environment where you have to spend a lot to have a data warehouse that can hold all the valuable data, I look at a data warehouse as a place for like that cached, ready for reporting, ready for analyst place. And so we're talking about structured data that's been processed and modeled for analytics use. Usually that processed and modeled for analytics use means it's slower to get the pipeline set up to load data to your data warehouse than it is to your data lake. This was my experience leading teams that were doing data warehousing, is we had a huge backlog, we had really important projects, and we couldn't get to them all because we were taking so much care to get that data right to put it into the data warehouse. In a data lake, you probably have some places you take a lot of caution with what you do with the data, But to start with, you can just get the raw data there and let people attempt to use it and come back to you with feedback to make their lives easier. Another reason for data warehouses, or another piece of data warehouse in my mind, is interactive query. We'll look at somewhat interactive query with a data lake with some pretty simple use cases, but you start to get to where it's taking more than a few seconds to run queries against a data lake. That's pretty typical, that it's going to take more than a few seconds to run these queries. If you're trying to work at the speed of thought, if you're an analyst diving into a problem, if you have 20 analysts diving into a problem, a data warehouse might meet those needs better. And BI tool support. There's connectivity to data lakes, but usually it's not that live connection. Usually you're going to extract a portion of the data from your data lake if you want people to be able to filter on the fly and do all the cool things that we typically do in our reports that are like semi-self-service reporting for business users. This is probably a good time to ask if there's any questions. Let me put myself on mute and see if there's any questions.
I don't see any questions right now, Dustin. I think we're all really excited and waiting for all the information coming through.
Sounds great. Thank you, Elena. So if you do have questions, even if they're about the first section, throw them in chat. We'll get to them. So what I want to do is look at querying data lakes with Azure Databricks. I'm going to give a very brief intro before we get hands-on. There we go. Azure Databricks is, as a data engineer, as someone that's worked in different cloud providers with open source technologies, I look at Azure Databricks as managed Spark. Managed Spark, Apache Spark is this big data processing tool. We'll talk a little more about that to fill everyone in. But I look at it as a place where I don't have to roll this thing out myself. I don't have to provision virtual machines. I don't have to worry about upgrading them all and getting all the files installed everywhere. I can let Azure Databricks do a lot of that heavy lifting for me and provide some easy interfaces for the customization I need to do to the cluster. However, it's more than that. And so Databricks, the product, calls itself a unified analytics platform. It's really bringing together a lot of capabilities based around Apache Spark, but we have some different interfaces like notebooks. We have tools for machine learning, ML flow, experimentation, ability to share, a lot of built-in security and permissions, which in Azure are going to actually share your Azure Active Directory users. So a lot of integration with other Azure capabilities as well when we're talking about Azure Databricks. And it is a first-class service of Azure. This isn't an add-on. It's a partnership between two companies that really integrates well within the system. And it has some really good capabilities that I at least had trouble doing on my own without a managed service. Auto-scaling the cluster when we see the jobs pick up throughout the day, auto-scaling the cluster up and then back down. And then auto-terminating, so I can say, hey, this is an analytics cluster. Marketing team's going to run queries all day. If no one's run a query in the last 2 hours, shut this thing down until the next query. And all that means is you have about 5 or so minutes of startup time the next time someone runs a query. So it's got its trade-offs, but it's going to save you a lot of money if it's a ad hoc, interactive environment you want to use for querying your data lake, and you need to do the heavy lifting that Spark's capable of. So with that, we will attempt our first live demo of the day. If you haven't worked with Spark, this is where we find out if our cluster or anything has restarted on us. Now, what we are looking at on the screen is a Azure Databricks notebook. If you've worked with Jupyter notebooks or Zeppelin notebooks or Azure Studio notebooks, it's got a lot of similarities, probably the most similar to Jupyter, I think. And as we go through, what I'm trying to show right now is I have data that's in Azure storage system. It's in a data lake. I'm going to query it using SQL from my Azure Databricks notebook. So if you are new to this and you're wondering what does it look like to query a data lake, this is meant for you. If you haven't really used Spark SQL before, let's take a look at just a couple of things and we'll talk about some table types. So I'm going to use the New York City taxi data. Here's our use case. We are trying to take a taxi company and make it into what Lyft is, or the best of both worlds maybe of Lyft and a taxi company. And in order to do that, we need to get good at processing the different trips that are happening, the customers that are taking those trips, the people booking the next trips, that kind of thing. And so we'll have a lot of legacy data we need to load. We'll have a lot of streaming data we'll work with today. But first, let's just query some data that's already landed into our data lake. The first example I have, which will really give you one perspective of a data lake, is a select count from a table that I've created. So I have defined this table. I'll show you that after we're done here. And this is going to run for about a minute. You might be thinking, this guy's crazy. Why would he run something for a minute in a demo? Basically, when you have raw CSV files that have not been compressed, that have not been modified for a good format for a data lake, it's going to be a bit slower to query these things. But what we're doing is we're actually querying that CSV files that would have been loaded without any manipulations happening, which means whoever's producing this data elsewhere and can only give them to us in this format can load it up. We apply a schema to it without moving the data again, and we can now query it. Another team could come along, apply a different type of schema that still fits that data. They could query it as well. Pretty powerful stuff, even though we're going to end up with a little bit slower time to get our count. And of course, as we do other things with the data, a little bit slower times. But don't worry, I'll show you how to speed that up in a moment as well. As that's running, I pre-ran this described for you. So the data we're working with, oh, there we go, just over a minute. So I was right on the timing. So we're working with 100 million records. Yeah. Quick way to look at stuff in notebooks, if you just need to see the number, is you can go to the bar chart option. I'll show you like one or two more charts today probably, but I don't do a lot of this. We have 100 million records in this table. We just queried CSV data live in 1 minute. Not too shabby, but we can definitely do better with our data lake. So just a simple describe command to show how you can like explore the data types and what's in the data. We really have like a fact table here. I don't have a lot of lookups for us today. We're really going to focus on just some really basics about querying data and doing a little bit of aggregation with that data. So we've got all kinds of information, including the tip amount and the charged amount. Now, we can look at a sample of that data. The top 10 is not going to take too long because it actually only has to go hit a certain file and pull back 10 records. It doesn't have to scan a year worth of data, which is what I'm dealing with these 100 million records. So what I want you to see here are two things. One, we do have data, we do have a schema. There's some amount of things we could query here, especially with these dates that I've created. We also have records that are all the way null. And even if you're new to data, I'm sure you know that these nulls, these blank values, means that something's up. When we're talking about external tables in a data lake, we don't really know that everything matches the schema we've asked it to. We might get some data type errors if it doesn't match. In this case, we're probably dealing with header records that don't match the data types. It might be that there's just null records in the data set. If you end up in this situation and don't know how to solve it, take a look at the sort of the modes of permissive. If you do a permissive mode, it'll tell you a little bit more about it. That's a whole nother subject. But you need to be ready for this kind of stuff if you're working with external tables in a data lake. You wouldn't want these records in your data warehouse, right? But it's not too bad if you're doing ad hoc things and can work through this logic yourself. The data I just showed you, we're basically doing a file system command listing out the files. The data I just showed you is 12 files, all in a single folder, New York City Taxi Raw, which is what my table's pointing to. And each of these is almost I believe 700 megs of data, almost a gig. I forget the math on that. So the way we would probably want to store this to have better performance in a data lake is a very simple introductory idea for data lake, but it's critical if you're going to try to even just do a proof of concept. We would want to store it probably as Parquet, probably Snappy Compress, which is the default Spark will do, and we would want to partition it in some way that's meaningful. So now I am going to build a table on top, or I built a table on top of this yellow trips detail folder. Within that folder, I have these subfolders, which are actually partitions I can reference for the year and the month. And then within that, it has multiple Parquet files that are a decent size, probably could be bigger size and still perform really well, maybe perform better, but a decent size that I've created with Spark. And so the key here is that we've switched to Parquet format. We have partitioned the data. Now when I do a simple count, this is still an external table, meaning I have a schema pointing at those files. I haven't had Spark load those into its own storage area. This count should be pretty quick, more than a couple seconds, but not enough to go get a cup of coffee is what I'm expecting. All right, 14 seconds. That's kind of what I thought, but I didn't want to say it wrong. So we've got the same number of records. We got that result back much quicker. It's not magic. I won't make you watch the 1 minute query again. That query would still take a minute. This one's 14 seconds because of Parquet format, because of the partitioning. Look at that data just for reference. It's going to look the same. I think I still have nulls in here. Maybe I had to filter those out for this to load. I can't remember if I did a little bit of cleanup for you. And then finally, there we go. So we've got the data, looks pretty similar to before. The nulls are not showing at the moment. Now, finally, just to show that you can do more than just count stars, we can do averages, we can do counts, as we're seeing in Command 10 here. And here I actually use my partition, which is always a good idea to get better performance out of a data lake. This is true of a lot of systems, but this is kind of as close to an index that you're going to get in a data lake. Databricks does some things, especially with Delta storage, that will help you out. Definitely some things to learn here, but if you're going to partition and store as Parquet, you've taken step one down building a decent data lake. So let's prove this works. We'll just get some totals. I don't know if I haven't tried plotting this one. So it's going to plot one. It's going to plot the average tip for me by ID, which isn't all that exciting, but apparently about $2.50 is the average tip. Good to know. So very briefly, let's look at our create table statements. We won't go through line by line, but I was talking about external tables. Basically, when I create an external table, it's just the schema, and you'll see down towards the bottom, I am specifying a location and specifying how the data is stored. And the other thing to know is if I drop the external table, the data stays there. I'm not impacting the data when I create an external table. This is similar to some of the polybase format, though I think how you define the file formats and where it's located is quite a bit different, if I recall correctly. Here's an example of how we could take that raw data and create a Parquet data set. I think this is actually the one I was showing you. No, I showed you external for part of it, and I showed you this for part of it. And so it's basically create table as a select statement. Pretty simple idea that you get the hang of quickly if you're new to this. And then we create external tables on Parquet. When we have partitions, there's a few ways to do it, but kind of the standard way is to just add in the partitions as they get loaded, which is what I've done here. So just a long command, all I did was copy and paste a bunch of times. And you can create temporary tables, which are kind of just for this session and don't show up for every other user. In this case, it's typically I create temporary tables by doing a create from a select statement or something like that. And I think that's everything I really wanted to call out here. We'll jump back to Databricks soon and look at some more stuff, but that's kind of the starting point of querying a data lake. Any questions at this point?
Hi, so I'm just going to read them out. So one of the questions actually earlier, and I thought that you might just cover it, but will you be sharing a copy of your presentation after the fact?
I think I will be. I might take some pieces out of it. I'm crafting this into something else, but I will share some of it. And on GitHub, if you go to github.com/datakickstart, I'll try and put that in the slides before I share them. You can see some notebooks that are similar to what I'm sharing if you want to take these and try them out. I should have mentioned, I didn't use the exact path in that notebook, but this New York taxi data is easy to find. I think you may not find the same year with Azure right now. I'd have to check. But you can find this taxi data, like if you spin up a trial Azure Databricks cluster, you can get a 14-day trial. You can probably connect to that data directly without having to copy it in and pay for the storage. So that's one of the reasons I use that data set, is because it's so easily accessible. Any other questions?
Great. Yes, so there's a question from Uday here. Will you be showing how to create a Databricks data warehouse?
So I'm going to show you how to load data into data lake storage with a streaming job. That's kind of the main big end-to-end type thing. What we did there is actually, once the data is landed, which is what I'll show you later, once the data is landed, we could use SQL to create those tables. We'll talk a little bit more about the different components we'll use with Databricks in order to build that ETL job. So I'm going to talk more about the loading process from here on and some of the tools we use to load it. If you have any more questions, though, as I'm going about building Databricks data warehouses, please mention those and I can talk to those. Also, I didn't mention it yet, but there's I think it's a data lake design patterns session, I believe in the same room, by Jason Horner at 1 o'clock. I plan to hop back on for that one, so definitely come to that one too and hear more about design patterns and data lakes beyond my introductory things. Any others?
Yes, thank you for that one. So there's a question from Eddie. Do you have any suggestions what scenarios best to use ADF data flow versus Azure Databricks?
Okay, I'll talk about that in a moment.
Okay.
Yeah, I'll talk about that in a moment.
Okay, great. Next question from Tito. Are those external tables just schemas over CSV files?
Yes, the first one I was showing is schema over CSV. The next one I was showing is just a schema over Parquet.
Okay. Oh, gosh, we're getting a lot of questions. Let me know if you want to pause
How
and go
about
back to questions
let's
later
do
so
one
you can
more and then we'll
cover.
come back to some more at the end.
Okay, so Uday, could you also give us some idea on cost if I spin up Azure Databricks in Azure Cloud?
You know, I should have put a slide together. I have trouble keeping tabs on the cost, but if you want to try it out, I would totally recommend a 14-day trial, which your cluster and your workspace will not be usable after the trial, if I remember correctly. For me, what I do is, when I spin them up, I do about 2 or 3 nodes. I tend to think of it as like $1 an hour per node. I really want to check that though. Please do not spin anything up without checking the pricing they say. But I use the smallest nodes. This one's just 2 or 3 worker nodes. And I set auto terminate to either 60 minutes or 2 hours if I have a presentation. And I don't incur a ton of costs from there. The storage, you have to remember, if you don't use the storage for a month, you'll keep paying for it. The Databricks workspace is free, so you can get started. You can spin up a cluster. Definitely set auto terminate. And do not take the default. I'll show you that in a minute too. I can show you that when I'm in the portals again. So yeah,
And
let's
just
keep
one
going.
last one, even though I know you said that was the last one, someone asked
I
to
trust you.
share the
What's up?
URL. Someone asked to share the URL, so I just wanted to get that out there. This was, if you could please share the GitHub URL. So
Yes,
just keep that out
I'm
there.
going to
And,
do that right now for you all. Maybe not.
and I'm done and turn it back over to you.
I will share the URL soon. Sorry. I'm not sure if my chat will make it to everyone, so let's focus on the presentation. Cool. Well, good. Sounds like people are interested in looking at that code more. There's definitely a lot more code we're going to look at, which might be a bit overwhelming for some. Maybe overwhelming for me, to be honest with you. But I'm going to share the link to that so you can go back and look at it if you want to really dig in and understand the individual lines that I used. And the configurations is really where things get interesting. So, question about Data Factory. Let's talk about a reference architecture for this new improved taxi lift company I made up yesterday. So what I would do, here's what I'm going to tell you. What I would do in Azure right now, we're going to have sources that are the web app and the mobile app, and that data is we're going to want the apps themselves to send the data to us, and we're going to collect it as it streams in, and we're going to at least ingest it in a raw form. We may even do our additional processing and transformations and loading of the data lake in a streaming or close to real-time fashion. So in a several minute chunk or 5 or 10 minute chunk, something that's much faster and once a day, I guess. The other thing we're going to have is a lot of data that's collected. Maybe at the end of the day, the drivers send a report of a bunch of information we need. We get our sales totals at the end of the day and we need to reconcile. Those things are going to end up in, let's say, databases. Maybe you're lucky and they put them in a data lake storage format for you and you can just query from there. I haven't really seen that happen, but it could happen. Now, those simpler batch jobs, that might be where you say, I just want to ingest this raw to my data lake. Azure Data Factory has some tools for copying data that are going to be pretty easy to use. Depending on the format and the schema, pretty easy to maintain. If your schema is changing a lot, you would need to talk to a Data Factory expert, someone smarter than me on Data Factory, to hear about if you should or shouldn't do it for changing schemas. But yeah, it has a lot of good copy tools. The other thing Data Factory does well that I would totally leverage and that I expect to leverage on some projects is orchestrating these different Databricks jobs. So if we have some built-in jobs scheduling that we can do. We have a REST API we can trigger Databricks jobs with, or we could have more of a dependency graph that we set up with Data Factory that could get triggered by certain things. Maybe we drive it off of a metadata table that tells us all of the processing that needs to happen and what to do on failures. We can do more of like an Airflow style coordination orchestration with Data Factory. That is a very good use case, I think, for using it if you're going to use Spark heavy as well. Mapping data flows, wrangling data flows, very powerful stuff in Data Factory. The thing to think about is who you're going to have on the team, what kind of custom work they're going to need to do, and whether Data Factory is going to fit them better or Spark is going to fit them better. For the type of work I'm doing, Spark has the most broad use for the types of data engineers I want to join the team, that I can find to join the team in the cities I'm hiring them in. And that's one of the drivers. The other is that I'm comfortable with Spark and know how to work through the problems I hit with Spark. Data Factory is kind of a new thing to learn. So certainly if you're going to do Data Factory instead of Databricks altogether, look at people like Simon Whiteley's presentations where they're talking about the right way to use it to not maybe recreate some of the problems we did in SSIS for many years. I'll leave it at that for this presentation. So in our example architecture, I'm not going to show any Data Factory today, but you could assume that some of this data makes it to the data lake with Data Factory. That could be a choice you make that I often would say, yes, great choice. We're going to have some of it come to Event Hubs, and I'll explain why. And then from Databricks, we'll take that data that's landed in the data lake. We might be triggering Databricks jobs from Data Factory, and we'll take the data coming from Event Hubs and process that, and ultimately land it in Azure Data Lake storage. If you were listening closely, you know that I said, hey, do some partial processing and land the data back into the data lake, do some full processing, land it back in the data lake. So you could picture kind of a cycle with Azure Databricks and data lake storage here. That's the way I typically do it. A lot of ways you can manage this though. So I just want to keep the reference architecture diagram very simple for us. And then I'll show you a little bit more convoluted back and forth to the data lake approach that we'll do soon. Data lake storage. Data lake storage Gen 2, there is a Gen 1 that's a very different thing. At this point, let's say you're starting fresh, I'm going to say just focus on Azure Data Lake Storage Gen 2 as your data lake storage. It's built on top of Azure Blob Storage. If you're new to Azure, but you know Amazon S3 or Google Cloud Storage, any of these distributed storage systems that works well with big data and analytics, this Blob Storage is one of those types of distributed cloud storage systems. But Data Lake Storage Gen 2 is built on top of it and is more compatible with these big data processing tools like Apache Spark and Azure Databricks. So it has Hadoop compatible access, because even if we're not using Hadoop ecosystem right now, Spark is using the Hadoop APIs. Other tools you might want to leverage are using the Hadoop APIs to access the files, and this is really important. The way we do permissions is optimized for analytics. The way it queries the data is optimized for analytics. It's just going to be a better fit if you're really doing these big data analytics on top of it. Azure Blob Storage can be pretty good as a feeding mechanism, though. I don't necessarily switch out all my source data to be ADLS instead of Blob Storage. And the cost is probably similar between ADLS. ADLS stands for Azure Data Lake Storage. I better get that out here. So ADLS is going to be a similar cost to Blob Storage, but you might pay more per transaction, most likely, I'd say, with most use cases. And so keep an eye on that. I always would like to do like proof of concept test and see what my actual bill is before I do a large project with it. So this isn't super critical for today, but basically you're going to create storage accounts in Azure Storage. And that Azure Storage account, at that level, you set that you want it to be Data Lake Gen 2, which is a hierarchical storage account. And that changes just slightly the way it's stored in a way that's really meaningful. So the container or the file system is that you would create that within the storage account. So I would say a data lake probably has multiple file systems, though you could try to do it all in one. And you're going to have directories underneath there. Those directories are real folders, or at least they work like real folders rather than just paths to files like blob storage. What that means is that when we move and copy the data, we're going to get better results than we would in blob storage. The files will then show up in the directories. Obviously, we have multiple layers of directories. And we can do permissions really throughout, I believe all the way down to the file level, though I don't really do it that way, but from the directory level up. And so we can give different users access to different parts of the data lake. So we're using Spark. Why are we using Spark? This is going to be the high level view. And I think I'm going to, since we have so many questions, breeze through this a little bit. So Spark is a leader in data processing that scales across many machines. It is easier to use than the MapReduce API, and because it leverages memory heavily, it is faster than the MapReduce API in most use cases. So basic idea with these big data systems, Hadoop, Spark, many others, is rather than having one really powerful, really smart system, we want a bunch of, or one really smart server, let's say, or one smart person, if we're doing the people analogy. We want a whole lot of people, because a lot of this work, if we just break it up into small tasks, can be done way quicker than just having a really powerful person doing it or a really powerful server doing it. It's also changes the way cost is cost is going to work, and that's something to really look into for your own use case, of course. So Spark is a fast general purpose engine. So I really like it if we're going to do a lot of different projects. I'd like to ramp the team up on Spark to know we can do this in Spark if we need to. Sometimes we find there's specialty libraries and things that really help us out. It, like I said, replaces MapReduce in many cases. It has many options to work with it. We will look at Spark, the Spark SQL APIs, and using Python primarily for that. Here's a quick snippet of Spark code. We'll leave this in there for reference later, and then just know that you kick things off to a driver like the controller on the side of your screen here, and then those get split up to workers, and the results may get written by the workers depending on where you're writing to, or they might come all the way back up to the driver, which usually adds a little bit of a bottleneck if you're collecting everything back to the driver program. Now, for Azure Databricks, we've looked at notebooks already, and we'll look at that a little more. You can also use PyCharm, VS Code, other IDEs. There's something called Databricks Connect that works pretty well, and so I will actually do my development in PyCharm, build out packages of code that are part of my ETL processing, and I can test them and unit test them, everything from PyCharm, and kick off jobs in PyCharm. You can use a REST API to trigger jobs, and that's something that is more how I tend to set things up. Databricks Workspace and some Spark code. I think we'll skip the Spark code and just look at the workspace again, or a bit more. So the quick overview of the Databricks workspace so that you know where I'm at. We have quite a few options, but your recent notebooks show here, and this is where I end up. You can see that there's support for ML flow, there's support for job scheduling. When you go in there, it looks like a pretty basic job schedule. You can even use cron syntax if you really love the cron syntax. You can create clusters, so there's multiple clusters within your Databricks workspace, and you can create tables, which typically when you do it this way, it's going to be stored on the Spark storage and managed by Spark more so than the external tables I showed you already. So on the side here, I have some browsing tools so I can see all the tables I've created. You can see I pretty much take 2 free data sets and create many variations on it. And then you can see all my clusters. I have a single cluster created for this. Maybe somewhat related to building data lakes in Azure Databricks is what size clusters to use. This is not a good example because it's a demo cluster, but I would say you're likely to want auto scaling on an interactive cluster that people are going to run notebooks against all day long. You likely will want terminate after a certain number of minutes, or you could just schedule it to turn off at certain times a day, turn on at certain times a day. I think it'll still auto turn on no matter what you set, which is kind of good. That you really want that, I think. You can set your min and max workers, and there's all kinds of worker type options. If you look at Azure Synapse Analytics, which I wish I could talk more about, but we only have 60 minutes today, they don't have as many different worker type options to choose from, but they do have some good options for you there. Their notebooks look different, and so that's something to consider. And the way they integrate with ML is a little different than ML Flow. So just some of the ways they integrate are different, but it's Azure Synapse. If you've started hearing about that, learn more about that. It's in public preview. We have some time to see how it performs in the long run, but you're gonna see a lot of similarities, and then you're gonna see some differences that are worth digging into for your own use cases. Probably the important thing to know is that you have a UI that I haven't done a whole lot lately that will let you see the different steps your jobs have run. One of the best ways to look at it, if you haven't done a lot of this, is to go to the SQL page, assuming you're using data frames like I am. And I have no really good example jobs right now, but you can click on a query, click on a job that was interesting, and try to understand what happened. So it read a bunch of Parquet data, it did some filtering, it did some projecting, which means like a select of column names. It did some hashing and aggregation, it did a shuffle, yada, 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 and it, I think, printed to screen. Maybe it saved that one, I can't remember. So we have that kind of UI to help us monitor. And then you can, it's a little more advanced, I really need to write this up, you can set up log analytics connectivity where your log4j logs go to log analytics and have a much easier way to view the logs. One more tip for anyone that's getting started but really wants to do this on a real project. Init scripts are really handy to install all the libraries, Python libraries or whatever that you need. And the logging section, when you set up your cluster, hopefully you can see the bottom of my screen here. The logging to a Databricks file system space. So this is like a managed Azure storage account. You can store all these logs there. And so if you have trouble seeing what you need in the Spark UI or the driver logs page, you have a spot you can go and really analyze these logs if you don't have them go into log analytics already. All right, so that's kind of a quick overview plus some tips on clusters for data engineers, people like me that are trying to do this. If you're submitting jobs via the scheduler or via the REST API, you might just want to have it create the cluster on the fly. It really depends on, how often that cluster needs recreated, how often it's going to spin up and down. But there's different cluster modes and you pay different prices for those clusters. One of the reasons I am careful not to be too strong on my language about the pricing. If you use the most basic cluster for data engineering workloads, it's a bit cheaper than the interactive one that uses all these notebooks and things with it. Okay, I think we will see plenty of Spark code in the last stretch here. So let's talk, apparently faster than I wanted to. I apologize, we're a little delayed here. Talk faster than I wanted to about Kafka and Event Hubs. So streaming data from one system to another directly with no middle layer tends to lead to problems. Either the publisher is way ahead of the subscriber, and then the publisher has to deal with all this buffering and things on its side, or the subscriber prefers to not be so on the hook to consume everything and wants the option to kind of replay data or wait and just check back in every 15 minutes or so instead of being true like real-time consuming. And so Kafka is the tool that data engineers, data architects tend to use across the industry for this scalable broker for streaming. So it's a platform that, let me move on to this slide. It's a platform that works as a distributed log. The blog article by Jay Krebs is a very long one. There's plenty of resources. This is a very good one about a append-only log, kind of like your database log would be in SQL Server, where all the events get put in order and we can then go and consume them in order and know what to do with them from there. So everything's written in order. You're going to talk about topics, and the topic is similar to a table name. So like one feed of data goes to a single topic, and that topic is partitioned in order to give a scalability. And the order that I talked about is maintained within the partitions. And so you want to make sure the key you use when you write to a topic is one that you want to keep order of records in. And basically the partitions is required for you to scale out consumers. If I want to have more than one service consuming the data for the same application, I need more than one partition. Super quick Kafka overview, but I hope that helps you understand why when I switched over to an Azure project, when I'm building a data lake, I said, well, at some point we're going to have streaming data. When we need to exchange data with the other applications that are consuming some of the output we have, we want to send that over a streaming system like Kafka so that we have a middle layer and multiple consumers can access that without us having to know all the details of each consumer, right? It's this middle layer that brokers things for us and makes life easier for the publisher, and I think adds a lot of really valuable capabilities for the consumer. Event hubs, we're going to talk about event hubs as being pretty much the same thing. It's the same core capability, and you can use the Kafka APIs with event hubs. You just have to set it up with the right tier, and you avoid a lot of overhead with managing Kafka. So this is what I've chosen to do. I've seen pretty good results so far. I will continue to keep an eye on it as I build out more production use cases with it, and definitely share if I see problems, but it's been working pretty well so far. And our C# developers can always use this Event Hubs API instead of the Kafka API. So this is just the translation. An event hub is a topic, and then you have an Event Hubs namespace, which is a collection of topics, okay? The other note, if you go try this at home, is basic mode does not support the Kafka, using the Kafka API, which I cut this slide out of my deck and was wasted an hour yesterday forgetting that and trying to go with the cheapest tier possible. So let's do a quick overview of how we're going to consume structured data. This is kind of our first view of Spark code. This is PySpark code. It looks pretty similar in Scala though. And what a read will do is basically you're taking a Spark session and you're calling read stream and you're telling it a format. So there's all these different libraries I can plug in for my read format. In this case, we'll use the Kafka APIs. And then I pass it a whole bunch of options. In this case, I'm just unpacking it as named values. You can see that in the code that I'll show. And if you're doing aggregations, you'll find that the group by looks pretty similar to what you would think a group by should look like in a language like Spark, but we have a column, in this case vendor ID, and then we're going to add in this this windowing to say kind of what time frame we want to be aggregating these results on. And this is a pretty important thing when it comes to streaming, to think about the windowing and the output modes you're going to use if you're doing aggregation. Often I'm just processing and writing those details somewhere else to be consumed downstream. So this is the main example for the rest of the presentation. Let me get us started here, and then we'll pause for some questions. And if you want to ask questions about the streaming demo, we'll go there. If you want to ask more fundamental questions, we can go back. So what I'm going to do is show you that we have set up a topic called demo message 1. We will have this config that I talked about. This is a little bit hard to find, at least it was for me. And so this example notebook's a good one to reference if you try this. And there's 2 important things. The consumer config is important. This will be your own Event Hub's name. And then the SASL string that you use that has this Kafka shaded piece, this is the other part that was tricky to find the right version of the first time. And this version should work with at least pretty recent versions of Databricks. So basically, we're going to set up this code. The next thing we would do is call really the same thing I showed in my slides, which is a Kafka read stream. But what we'll find is when we get back a message from Event Hubs using this Kafka API, we have like a topic, a value, and a bunch of other stuff. The data record's really in the value, and it comes through as bytes. And so it's not going to output anything yet. This is just the setup. But I'm going to convert from a bytes to string right here. And what I have now is a JSON formatted string. So I define a schema. In Spark, a schema is really a struct type object. And in this case, I just loop through column names and build a pretty simple one. And then really the important piece is right here. I'm doing a select from that data frame. So this is where I loaded the data initially. I converted it to strings. Now I'm calling this from JSON function, which is going to say, give me a JSON string and give me a schema, and I will give you a JSON object back. And so now I'm going to be able to reference everything as JSON.vendor ID, JSON.payment type. I really just want to flatten it out. And so to flatten it out, I can do select JSON.star. So just like a select star in SQL, that will select everything for us. From there, you can do things. This is something I do all the time. I usually wrap it in a transformation function, but we'll keep it simple for today. You can do a with column to then add on a new column called trip distance using an existing column called trip distance. So we're actually replacing it, and we're casting it as a new data type of double. And then we'll display our trips. So this is probably as much as I'll show until we see what other questions we have. Sorry, wrong button. So I'm going to get everything set up above it. All right, we're caught up. Now this is the piece. Spark is lazy evaluating, and that's a much bigger topic, but basically all that did was tell it the plan I want to use. It has not triggered an action, but as soon as I call this built-in display, it's going to trigger an action that says pull back a bunch of records to show on the screen for me. And so this is going to kick off a streaming query. In the background, I just started my streaming job that's just looping through a file and sending a message every second or 3. And you can see that I've ended up with data that looks very much like we saw before. But in this case, I've taken the raw data, passed it through Event Hubs, and read it back out on the other end with just a little bit of data type changes so far. And so you'll see that'll update by default. It's like every second it's going to grab the next batch. So it's really a micro batch system to get this data really quickly. To do aggregations, we already looked at that code, but we could run aggregations here, see a little bar chart change over time. And then more with columns, more conversions of things. And then to produce, the config looks a little different. So I'll have that in the notes for you, how it looks to produce. When we're producing, we need to set up a key and set up a single field that's our value. So we're taking all that stuff we did in the data frame, packing it back into a JSON string to send along. And that could be a little magical if you haven't seen that before in Spark. And then the only other thing that these other pieces are meant to show you is that we often will have multiple layers that use Event Hubs so that multiple consumers can grab that data. So we might write back to Event Hubs and then consume from it again to do the next layer of ETL, let's say. And if we're using the data lake to store that data, we probably want to use a Delta format, which is a Parquet format, but it has a transaction log and lets us stream the data in and read it back out in batch with some isolation levels and with some updates and deletes supported, which isn't true of normal Parquet. So with that, since there's a great design patterns session later, why don't I just take a couple of questions, maybe one question, Elena, and then we can wrap this up.
All right, let's do, I see a question from John here. What are the pros and cons when choosing file formats, when choosing Parquet, CSV, etc.? Is it correct to say Parquet format is more popular format related to cloud services?
The 5-second answer is yes, Parquet is more popular for analytics services, for data lake querying. Avro is another really popular. So what's really important is to think about the compression, to think about whether you want it column stored or row stored. For analytics, we often want it column stored, which is what Parquet does. Avro is another really popular one that is row store, and for sending data over Kafka, I've used that quite a bit. With the Delta format, which I said uses Parquet, you can do some schema evolution, which is it's always a little tricky in practice, but Parquet, Avro, Delta, you store the schema with the data. So you aren't really waiting till the end to apply the schema, like I said. You're kind of defining that pretty early on in the game, and then you have to evolve that schema, and you have some of those complications that come along. So looking at if it's splittable when you're hitting it with Spark is important. If you're going to compress CSV files, look at if they're splittable or not. Look at what size files they tell you. Small files are a problem. All right, so that's the 1-minute answer, and I think I'll cut off there. Good conversation to keep having, though. Do we have time for one more?
We have a bunch of other questions. I'm going to pick the shortest one, and the question is, what is a good resource to learn Spark? And I don't know if you maybe have links. Maybe it's something you can include when you share your presentation. I think maybe that would be helpful, or if it's something that you can just tell us, that's great as well.
Yeah, let me add some links. I don't have the perfect answer for you there, though. Definitely check out my blogs on my website, dustinvannoy.com. Not because I think that's the best place to learn Spark from scratch, but I've got some resources referenced there, and I'll try to include some more that I've found. If you find one that's just this great end-to-end, though, please tell me. I found lots of really good ones, but they're either a little slow or skip too much. It's hard to find the perfect one, so I'm open to suggestions on that too from the audience.
You know, I do a lot of learning on Pluralsight, and I know Pluralsight is maybe a little pricey. I also go with Udemy a lot, and you can preview some of the things that they have available on there, and it's very inexpensive. So give that a try. I purchased one Spark course, but I haven't started it yet. I've been working on the SQL Saturday, but it's a resource. Check it out.
Yeah, I get one real quick note. If you don't program in Python or Scala yet, or Java, let's say, if you don't program any of those three, I would recommend learning Spark with Python. But a lot of resources do teach it in Scala, which is a great language to learn. It's just probably a heavier lift for many people, in my opinion, than learning Python. So that's my recommendation, and that's why I'm not sure which Pluralsight course is best, because a lot of them are in Scala. But there's some good ones out there. I'll include some links, yeah, when I upload some slides.
Great, thank you. Thank you, Dustin. That was a great presentation. Thank you so much.
Thanks, everyone.
Thank you.